All right, so this is our reference angle lesson. It's very, very important. I keep saying that over and over, but this is so important to the rest of your pre-calc career. By the end of class, every student is going to be able to identify the reference angle for any given angle. So as you notice here, there's a picture. The reference angle is this little guy right here. So 115 degrees, it's whatever gets you to 180. So 180 minus 115. What do we get? 7, 5, 6. So 65 degrees would be our reference angle. Now reference angles are always positive. We'll look at that. Tonight's homework is this. They're even problems, so we will have some posted homework answers for you. All right. So I wanted to start you off with just identify what are the quadrantal angles. So we talked about the other day where like, okay, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. But a quadrantal angle doesn't lie in any of the quadrants, it lies really on the axes. So if this is 0 degrees, the first quadrantal angle you come to would be 90 degrees, and then 180, and 270. You want to be familiar with these because it helps you to estimate where your angle is going to be. If they say, okay, find the reference angle of 280 degrees, you want to be able to quickly go, okay, well here's 270, that's my reference, and then it's 10 more. So you want to be able to say, okay, this right here is about 280 degrees. And it doesn't have to be exact, but then we can find our reference angle. Okay? All right. Let me undo that. All right. So a reference angle, it says if theta is a non-quadrantal angle. So we just talked about the quadrantal angles. So if it's an angle that's not on one of the axes, in standard position, its reference angle is defined as the acute angle formed by a terminal side of the given angle in the x-axis. So let's talk about what acute means real quick. Acute means anything between 0 and 90, but not equal to 90. So it has to be less than 90 degrees. A theta less than 90 degrees. All right, so an acute angle is less than 90 degrees. So if I have 160 here, my reference angle is going to be right here. And we need to think about, okay, well, how much to get to 180? Well, I need 20 more to get to 180. So 20 degrees is my reference angle. So I'm just going to put r equals 20 degrees. And that r is just what my reference angle is. Okay, so here I've gone all the way around. So we always have to drop it back to the x-axis. I'm never going to go to the y right here. Always go back to the x-axis. And I want to think about, okay, for this one, I passed 180 by how much? So I might go 242 minus 180. So 2 minus 0 is 2, 4, that can't, so 8, 9, 10, 4, 5, 6, 62. It looks like we went 62 degrees past 180. So our reference angle is 62 degrees. Now notice they're always positive. This is a positive reference angle, this is a positive reference angle. Even though it's below, it doesn't really matter. We're just going to deal with positive numbers. All right, so here, 306, we need our reference angle is going to be right here. To get back up to there, to 360, I would take 360 and subtract 306. So we'd have 54, I think. Do you agree? So reference angle would be 54 degrees. Here, reference angle 62 degrees. Here, 20 degrees. All right. So if we look at this, there isn't one rule. I'm sure you can find rules, but here we had to go 180 minus 160. Here we went the angle minus 180, and here we took 360 minus the angle. So you really just need to think about each one and drop it back to the x-axis to figure it out. So here, what would we have? Let's see. Our reference angle is here. Even though it was a negative angle, this is not going to be negative. We need to think, okay, to get to 180, right? That's our next quadrantal. So 180, take away 133, 7 minus 3 is 4. It looks like 47 degrees. I can do a quick check, add that 10, yep, 180. So 47 degrees, positive angle. Last one, right here. So I went past 180 by how much? So 180, I could think, okay, well, I needed 20 more to get to 200, and then 37 more to get to 237. So in total, I needed 57. So this should be 57 degrees. But we're only doing positive. It's not, there's nothing negative about it. Our reference angle is 57 degrees. So this reference angle is not measured from the standard position. It's just from the x-axis to the angle, either up or down. Okay? I want to say that's it. So there, then now there's a worksheet, and I want you guys to work on it in my 7th period while I'm making this video. I need you guys to focus. Even though I'm not here, I know you can get a little talkative, but please get focused. Try these. In order to do this well, I'd really like you to sketch a little graph and think about, okay, from here I went 90 and 114. I need you to draw a little sketch and show me where is that angle going to be. So if this is 114, how much more did I need to get to 180? So 180 minus 114, so we need 6 and we need 6, so 66 degrees. So my reference angle is 66 degrees. That's what I'm looking for. If you just have 66 written, that's not showing me that you're really thinking about it. And this, I know it seems like a lot of practice, but you need it. Just draw the sketch, negative, okay, let's see, negative 270 would be right here. And then 285, well, that's 15 past right there. So how much more would I need? Okay, so think about it carefully and figure out what the reference angles are. I don't know if there's anything else. I guess that's it. All right. I was maybe going to start you on like thinking about 0 degrees. This is 30 degrees, 45 degrees, 60 degrees, 90. And then we were going to keep going around, so 270, 180. But I think we can do that later. I think you just need to practice the reference angles. Okay. Yay. Thanks for listening to the video, and be good. I'm sure your substitute is a wonderful person. I will be back tomorrow.